Hey everybody, welcome to my AP Calculus Unit 4 review. Today we're going to be talking about the contextual applications of differentiation. So we're going to talk primarily about motion and related rates in this episode, and a few other topics that I want to throw in. Obviously I'm not going to be able to cover every little thing about like motion and everything, but I'm going to try my best to include as much as possible. So yeah, let's get started because this is going to be a pretty busy video. So we're given this function that denotes the position of a particle at any given time between 0 and 9 seconds. So we're measuring this in seconds, and this position is measured in feet, okay? And so our velocity, we want to find the velocity and the acceleration first, because that'll help us throughout the rest of the problem, because there are like 9 or 10 parts to this problem. These are just the first two. And so having these will definitely help us out. They won't help us in these first two. Actually, I think it will. I think the velocity is going to help us here. But yeah, so let's just get started. So we're going to talk about a lot about motion. So pretend this is like a particle moving around or something. And so part A asks, what is the displacement of the particle from 1 second to 9 seconds? So what we're going to do is we're going to... well, actually, let's think about what displacement means. So if I have like a point here, and then another, so my starting point is here, and my ending point is here. So I can go in any way I want. So let's say I go this way, and then I go this way, and then I go this way, and then I go back here. The displacement is not going to care about how I get there. So it's just going to care what this minus this is, and that's it. Our distance traveled, on the other hand, is going to care about how much distance we cover. So like if this is like 10 feet plus 5 feet plus 15 feet plus another 5 feet, or say whatever, it's going to add all those up, and that's going to be our distance traveled. So our displacement is basically just the endpoint minus the starting point, and that's it. So our distance traveled is going to be positive, always positive, and the displacement can be negative, because if we started here and then ended here, it's different than if we started here and ended here. So let's get started with that. So the displacement, basically I said, is just the ending point minus the starting point. But what do I mean by that? I just mean the position at the end minus the position at the beginning. So that's going to be s of 9, so our end minus s of 1, because s means position. I don't know why. X sometimes also can mean position. V is obviously velocity, and A is acceleration. So we're going to do s of 9 minus s of 1. Okay. And so from here, we are going to, we could just plug it in. So we don't need any of our velocity or acceleration right now. I actually intended to solve these at the beginning of the video, but I'll do it after this problem. So s of 9 minus s of 1. So s of 9, basically you just plug 9 into here, and you are going to get 54. So it's 54 minus, and then s of 1, if you plug 1 into this, you're going to get negative 2. So it's going to be negative 2. So it's 54 plus 2, which is 56. But we can't just leave it as 56. We have to say what unit it is. That's going to be feet, because we traveled 56 feet. We didn't go 56 feet per second or second squared or anything like that. We didn't go for 56 seconds. We went 56 feet. That's our displacement. All right. And then actually, let me keep this here. Our distance traveled. This is going to be a little different, because what we're going to do is we have to find each point where we okay, so actually let's think about it. So pretend this is like one-dimensional motion where we're just going like backwards and forwards, basically. So positive, negative. That's the I forget the convention that we use. Positive is this way to the right, and then negative is to the left. So basically this is positive because it's going in the positive direction, and then negative, positive, and then negative here. So what we can think about is we'll say, all right, well, how do we determine like where our velocity is positive versus negative? Because it's velocity that we're measuring here, because we're moving at a positive rate. It's, and that's what velocity means. And we're going to figure out each time where we go from positive to negative or negative to positive, just so we can basically, just figure out like what we subtract off, what we add in, all that kind of stuff. I'll show you what that means in a second, but to find that, we have to find where our velocity is equal to 0, where we stop moving. Because then we can just determine from there using a sign chart what we do. So I'll just show you what that means in a second. First, let's calculate the velocity. So basically, our velocity is just going to be the derivative of the position. Velocity is just a rate of change of position with respect to time. So let's just do that. So it's going to be 3t squared minus 24t plus 36. And then just because, let's just do the acceleration, even though that's not going to help us during this problem. But it's pretty easy. We just do the power rule again. So that's going to be 6t minus 24, and that's it. Alright, so our distance traveled. So let me move this diagram like over here. So we'll go like that, and then this, and then that, and then back that way. Something similar, basically. And so, yeah, so our distance traveled. So we're gonna think about each time where our velocity is 0. So I'll just show you that. So if we take v of t, which is 3t squared minus 24t plus 36, and then we're gonna set this equal to 0. Basically, I don't know why I did it so long. Let me just make it a little better. So we're gonna set this equal to 0. So first we just factor it, so we can say that this is going to be 3, we can factor 3, then t squared minus 8t plus 12 equals 0. So then we can further factor this. This is going to be negative 6, negative 2. Yeah, so t minus 6, t minus 2 equals 0. And from here we can say that t equals, we'll just say, we'll switch the order, positive 2, and t equals positive 6. Let me actually just flip it up here. T minus 2 and t minus 6. Okay, that makes more sense. So, what does this tell us? Well, this tells us that our velocity, when our velocity is 0, okay, that means that we're not moving, we stopped. So our velocity would be negative this way, positive this way, and then if it's 0, we're stopped. And the times when we are stopped is at 2 seconds and 6 seconds. So what we have to do now is figure out how much we've traveled between 1 and 2, so 1 and 2, 2 and 6, and 6 and 7. So actually before we do that, we have to determine what's positive and what's negative. So let's do it. Let's make a quick sign chart. So we have, we'll start at 1 all the way to 7, and then we have 2 and 6 in between, so 1, 2, 7, 6, or I'm sorry, 1, 2, 6, 7. And then we determine whether it's positive or negative. So what we can do is we can just really just plug in numbers into here to figure that out. But actually we can, let's just do that. So so 3 times like 1.5 squared, let me see what I put here. If we plug in like 1.5, we're going to get a positive number here. So we're going to get a positive, and then we're going to get a negative, and then we're going to get a positive. So if you just plug in numbers between these two into here, these two into there, and these two into there, that's what you're going to get. Another thing, you can use multiplicity if you know what that means. I'm sure there are videos on YouTube about that, but I'm not going to go into that because that's a whole thing. But yeah, so this is what we get. So what this means, and I can put that this is our velocity. So what this means is that this is our velocity. Our velocity is positive between 1 and 2, negative between 2 and 6, and then positive again between 6 and 7. So now all we got to do is calculate s of 1, 2, 6, and 7. We have to calculate our positions. We're going to take this difference, add it to this difference, then subtract off this difference. So s of 1, so s of, actually, where am I going to do this? I'm going to erase this part here, just so we can have some more room. So s of 1, and then we have 2, 6, and 7, so s of 2, s of 6, and s of 7. So what did I get for each of those? I guess we get -2, 1. Yeah, so we get that this is -2. Yeah, and this is what we got earlier. And then 7 we actually don't have. So 2 is 5. And we got -27. And then s of 7 is -20. So basically, these are our positions at each of these seconds. This is what we get if we plug it into our s of t function. And the way you would like determine what function you plug it into is you just think about it. So you're trying to find the distance traveled. That's not really going to have much to do with velocity, or nothing to do at all with acceleration. The only reason we have velocity here is because we're trying to find where it stops, right? And actually, this is not the velocity. Yeah, this is velocity. So yeah, actually, we do have something to do with velocity. But when we plug it into our distance or position function, we're just trying to find like whether it's like positive or negative, and then from here we just kind of we determine. So the difference between here, these two, is 7. The difference between these two is 32, and then we get another 7. And here you can realize that, like, okay, well, some of these are positive, there should be negative, but really this is distance traveled. Distance is always positive, so we just take the absolute value of the differences between these, and that's it. So that's what we get. 7, 32, and 7. We just add those together, I believe. Yep, and so then we will get 46 feet in total. So this is the distance traveled, and that's it. So yeah, that was long. But yeah, let's just keep going. All right. So now the question is, when does the particle move left? And we already did most of the work that we need. This is all from that last question. Basically, moving left is just moving that way, right? Which is negative direction. And this again is our velocity sign chart. And our velocity is negative between 2 and 6. So that means that our answer is, it's going to be within parentheses, 2, 6. The reason why it's parentheses and not brackets is because you can't really move at one point. You can move over an interval, but you can't really move at one point. That just doesn't really make sense. So you use parentheses for that. And so that's it, basically. A lot of times if it's like problems like many problems in a row, you can just use what you have, the work you have for the previous problem, and you're good. So when is the particle's acceleration positive? Okay, well, we kind of just do the same thing. So we take a of t, and then we say 6t minus 24, set that equal to 0, and then we can actually just really easily solve this. 6t equals 24, that tells us that t equals 4. Okay, so then we can set up our sign chart for 4, and this is between 1 and 9. Again, I have 1 and 9 here. On the last one I have between 1 and 7. But 9, we go all the way to 9 because it doesn't have any restriction like 7 or anything. We just go all the way to 9. Actually, this is between 0 and 9. Sorry about that. So 0 and 9. This is also between 0 and 9. Wait, is it 0 or 1? Yeah, no, 0. Okay, so, yeah, so basically, we just, we just figure out where it's positive. So if we plug in like 2, or actually let's say 1, so 6 minus 24, that's a negative number. This is a positive number. So we are positive between 4 and 9, and that is it for that problem. So pretty easy. Let's move on to the next two. Alright, so now we have, when does the particle speed up? Okay, so speeding up, speed means, so this is basically just speed increasing. Speed is the absolute value of the velocity. And basically, when you want something to speed up, the acceleration and the velocity both have to be the same. Think about it this way. Your velocity is increasing when you're speeding up, right? But your acceleration is also increasing at the same time. I mean, I'm sorry, they have to be like the same signs. So like if your velocity is positive, so you're moving this way, so like you're moving this way, and your acceleration is also increasing, so you're going like faster and faster. That's when you're speeding up, right? When you're slowing down, let's say you're when you're slowing down, actually or I'm sorry, speeding up, continuing, or you have you're going this way and you're going faster and faster, so your velocity is negative and your acceleration is also negative because you're going that way, right? So that's when you're speeding up. So acceleration and velocity have to be the same signs. So they both have to be either both positive or both negative. And slowing down would be positive and negative, negative and positive, something like that. So speeding up, this is pretty easy. That is between 2 and 4, and then 6 and 9. So 2, 4, 2, 4, and then 6, 9. That's a bad 6. There we go. 6, 9. You can put like a union symbol, like a U, or just a comma. That's all you need. And then slowing down would be between 0 and 2, and then 4 and 6. I will definitely make a video about kind of why this is true. It's based on how speed is the absolute value of velocity, taking the derivative of that, and then Anyway, so what is the minimum velocity of the particle? So think about absolute minimum, right? And so we can think of like some graph here. Let me put it over here. We think of some graph like that or something. You have an absolute minimum. Well, you have a relative minimum here. If your graphs continue to go this way, then that is your absolute minimum, right? So you have like relative minima here and here, and obviously here, but this is your absolute minimum because it's going to keep going up that way. So this is your lowest point of your graph, and you want the lowest velocity. So that means, so you can find your absolute minimum by finding where your okay, so hold on. So let's say this is f of x, right? And you can find so you can notice how your slope is going from negative to positive here. Your slope goes from negative to positive. Your absolute minimum is where your f prime of x goes from negative to positive. That's it. So in this case, we want the minimum velocity. We don't want the minimum position, we want the minimum velocity. So we want the derivative of velocity, which is acceleration, and we want to find where that goes from negative to positive. And that's it. So we'll take, we actually had this already, so let me just redo it. So 6t minus 24 equals 0, and then from here, this gives us that t equals 4, right? I would just do 6 times 4 minus 24, that gives you 0. Then we just had our acceleration sign chart. And obviously we're going from 0 to 9 with this 4 here. We had this negative and positive. That was pretty easy. By the way, this double like sign chart, only do that for the speeding up. The rest just do like these single sign charts. You don't really. There are many different ways to do the sign charts. This is kind of a weird way to do it, but it works best for this, but whatever. So basically, negative to positive, our derivative goes from negative to positive at t equals 4. So that means that our minimum velocity occurs at t equals 4, but we want to know what it is. So we know that it happens at t equals 4. So that's cool, but we want to know what the velocity is whenever we get there. So all we gotta do is plug it into here. So if we plug it into there, what are we gonna get? We're gonna get that it is negative 12 feet per second. So negative 12 feet per second. That is our minimum velocity. Okay, so you need to be able to figure out if they're asking when it occurs or what it is. If it says what, then actually find it like this. But if it says when, you really just need like a time. And if it was when, you would just say 4 seconds, like that. You would just say, you always need to include the time or like the units. If it's an interval, you can't really put units, so don't. But if it's a question like this, then yes, put units. Put units when you can, basically. I mean, you can just say 2 to 4, 6 to 9 seconds. Like, you can put seconds here if you want. But yeah, so let's move on to the next few problems. So yeah. Alright, so we got these last 4 questions here that are going to go by pretty quickly since we already found most of our information. So the first one is basically, when does the particle stop? And we already found that, right? Because that's when our velocity was equal to 0. And that occurs at t equals 2 seconds and t equals 6 seconds. So that is our answer, right? That's where velocity was equal to 0. That means where the particle stopped. So you can say t equals 2, 6 seconds. I just like to do it this way. And what is the acceleration when it first stops? So we take, when it first stops, 2 seconds, because this is the first and the second. So when it first stops, we take that, plug it into here. So 6 times 2 minus 24. So that's going to be 12 minus 24, which is negative 12. And the units are feet per second squared. So feet per second squared. And that is what the acceleration when the particle first stops. Right? Super quick, find the instantaneous velocity at t equals 1. Instantaneous is always the derivative, because the derivative is the instantaneous rate of change. So all we gotta do is plug 1 into our equation here. So v of 1 is going to be equal to 3 times 1 squared. So that's 3 minus 24 times 1 plus 36. So 36 minus 24 is 12. 12, and then plus 3 equals 15. And the velocity is going to be feet per second. I'm feeling that's not right. It is right. Okay, cool. So yeah, it's 15 feet per second. And the average velocity from t equals 0 to t equals 1, average velocity, that is, so think about it this way. So if we have a graph here, like that, the instantaneous at like any point is just like the slope of the tangent line. The average is just if we take this dotted line all the way here. So it's the like if we drew like a straight line between here and here, that's the average velocity. So that's just what we learned from algebra, right? So the average velocity is going to be s of 1 minus s of 0 over 1 minus 0. So s of 1 minus s of 0 over 1 minus 0. Now, don't plug it in, don't do v of 1 minus v of 0, s of 1. Because if we did average, so average velocity, this is the rate of change in the position over the rate of change in time. So don't get it confused. Don't think, because if you plug in v of 1 minus v of 0, that's like the average acceleration, basically. It's kind of weird, but yeah, so make sure not to confuse that. So change in position over change in time gives us the velocity we need. So this is just 1 minus 0, which is 1, which kind of just, we don't actually, here, yeah, actually I'll keep it there. So s of 1, so what is s of 1? S of 1 is negative 2, and then, yeah, so it's going to be negative 2 minus, all these are 0, negative 27, over 1, so I'm not even going to put it, and this is equal to negative 2 plus 27, or you can think about that as 27 minus 2, which is 25, and again, this is going to be feet per second. Again, I feel like that's not right. It is right. Okay, cool. They're very basic questions, but yeah. And don't worry, I only felt like it wasn't right because I didn't really recognize the answer. Don't, like, you know. But yeah, so these are some questions here on motion. So let's quickly go through a related rates problem. And before I do that, so these are so many different kinds of questions that they can ask you. There are a bunch more, so definitely check out some other resources. I'm sure there are a bunch of videos on YouTube about them. But yeah, motion problems are a big part of the AP Calculus exam, so pay attention. Anyway, so yeah, let's get into related rates. Hey, so that's actually it for this video. I didn't realize it was going to be so long. So yeah, that's it for the motion stuff. And in the next video, we're going to talk about the related rates and the linearization, and a few other things. So yeah, thanks for watching, and I will see you in the next video. Bye guys.